Alright, what's up guys? In this video, I'm going to pick up some linear algebra. I'm going to show you guys how to multiply matrices. So we're asked to multiply the given matrices here. So we have two matrices here. They are of the same order. Matrix A here is a 3 by 3 with the following entries, and matrix B is also a 3 by 3 with the following entries. And what I mean by 3 by 3 is there's 3 rows and 3 columns in both matrices. So, quick information on multiplying matrices. Most students do not like matrix multiplication, and the reason why they don't like it is because matrix multiplication is not done the same way that adding and subtracting matrices are. So if you remember, when you add and subtract matrices, you're basically adding and subtracting corresponding entries. And that's why when you're adding and subtracting matrices, the orders of the matrices need to be the same in order for you to add and subtract them, because of the nature of how you add and subtract the matrices. But matrix multiplication is not done like that. Matrix multiplication, what you do for matrix multiplication is you take the rows of the first matrix and you multiply them by the columns of the second matrix. So it's basically the dot product when you think about it. And for matrix multiplication, the matrices don't have to be the same size, but the number of columns in the first matrix must be equal to the number of rows in the second matrix in order to multiply them. So they don't have to be the same size as long as it meets that criteria. Now in this case, the matrices are the same size, and obviously if they're the same size, that's perfectly fine, but they don't have to be. You just need to make sure you keep that in mind. So how can I tell whether I can multiply them or not? Well, let's just quickly, before we start, let's just take a look at some examples here, and I'll just talk about it. So let's say that I want to multiply a 2 by 3. Let's say I want to multiply it times a, I don't know, 3 by 2. So can I multiply these? Here's the way you tell. Since we know that the number of columns in the first matrix needs to be equal to the number of rows in the second matrix, the easiest way to tell whether or not you can multiply them, if you look at these two numbers here, we have a 3 here and a 3 here. If these numbers are the same, you can multiply them. If they're not, you can't. So in this particular case, we have a 2 by 3 matrix that we want to multiply by a 3 by 2. Well, can we multiply them? Sure we can, because we have a 3 here and we have a 3 here. So these two numbers need to be the same in order for you to multiply them. Similarly, if I have, let's say I have something like, I don't know, let's say a 2 by 4, and let's say I want to multiply that by, I don't know, a 3 by 3. Well, can I multiply these? And the answer is no. The answer is yes here, but it's no here, because here we have a 4 and here we have a 3. So the number of columns in the first matrix is different than the number of rows in the second, so we cannot multiply them. So that's the way you tell if you can multiply them or not. Now, I did want to do a video on matrix multiplication because it will surprise you that a lot of students don't know how to multiply matrices. It's actually very common for students to not know how to do it because it's not done the way addition and subtraction of matrices is done. So I just wanted to do a quick video on showing you how to do it. Okay, so since we're dealing with matrix of order 3, it's going to be a little bit more work. Make sure you have a calculator with you, because that's the biggest mistake as well with these matrices. It's arithmetic related mistakes. And so since we're multiplying these matrices together here, we got a lot of multiplying to do. So what I'm going to do is I'm going to do the multiplication by, obviously, kind of split them up into parts by rows, and then we'll write our resultant matrix at the end. So let's begin by doing that. So let's start with our first row here. So for our first row, that'll be 1 times 2 plus 2 times 1 plus 1 times negative 9. Okay. Again, multiply the rows of A times the columns of, or by the columns of B. That's how you tell. So again, make sure you have your calculator, but this should be pretty straightforward to do. Looks like we're gonna get negative 5 here. So again, we're dealing with the first row. So what we get here will be the entries in the first row. Okay, so I just want to specify that. Let's move on to the next one. Okay, so for the next one, we'll have 1 time, and notice that we do have negative numbers, so you do got to be a little careful. So we got 1 times negative 2, that's going to be plus 2, times 5 plus 1 times 11. And we need to do that as well. Okay. This looks like this is going to give us a positive 19. You can check me on that, but I believe I'm correct on that. And then the last entry for our first row. Okay, so that's going to be 1 times 4 plus 2 times negative 6. And it's going to be plus 1 times 14. So if you're familiar with taking the dot product, this is something that's not hard to see. All right. Looks like we're going to get a positive 6, but I'm going to check just to make sure. And if you're unsure, you probably should be checking. So make sure you do that. So I'm just going to, just as a way to check, just to validate. Yeah, it's positive 6. Just to validate whether or not it's correct, you want to plug it into the calculator. So make sure you're doing that. Okay, so now we're moving on to the second row. That's what the second row entries now. That's what we're getting next. So let's go ahead and get those. Same procedure. For negative numbers, put parentheses around them. That way you can lessen the chance of making an arithmetic-related mistake. So it'll be negative 4 times 2 plus 5. It's going to be times 1 plus 6 times negative 9. So you want to do this slowly. I think that's going to give us negative, I think it's negative 57, but I'm going to check. So it's going to be times 2 plus 5 times 1 plus 6. Multiply that by negative 9. Yeah, negative 57. So use a calculator to check. Let's go to the next one. Okay, so looks like we got negative 4 multiplied by negative 2. Then we'll add 5 to that. And then we'll multiply by 5. And then that's going to be plus 6 times 11. So we got to see what we get here. And again, since we got negative numbers, in order to lessen the chance of making an arithmetic related mistake, we will plug it into the calculator. So if you're doing this with me, you should get 99. And then we're almost done with the second row now. And then we move on to the last. So we have negative 4 multiplied by 4 plus 5 multiplied by negative 6. And notice how, again, I am using parentheses to for the negative numbers to lessen the chance of making a mistake. So as we go, we see what we get, and we got a bunch of negatives. So we want to be sure that we're not making any issues or making any mistakes. All right, so if you're doing this with me, you should get 38. Also, make sure that in the calculator you put parentheses around the negative numbers as well. Sometimes the calculators can make a mistake if you don't put it in correctly. Okay, so that's the second row entries. Now we just need the third row entries, and we'll pretty much be done after that. And we'll get our resultant matrix. Okay, so hopefully this is making sense. If it's not making sense right now, that's perfectly fine. Since multiplying matrices of this order, which is of order 3, is obviously requires a little bit more work. So if you're learning this for the first time, I would not start out with 3 by 3s or anything like that. I would just start out by multiplying a 2 by 2 times a 2 by 2 or something like that. You don't want to start out multiplying matrices, especially if you're doing the first time, by a matrices that may be of this order, because it's a little bit of work and it's very easy to get lost. So give it some practice. So now we're moving on to the third row entries. Same scenario here. So it looks like it'll be 2 times 2 plus 2 times 1 plus negative 2 times negative 9. So I think we're going to get 24 there, but I'm going to check just to make sure. And so it looks like, yep, get positive 24. So this would be 24. So that's the first entry in the third row. We need now the second entry in the third row and the third entry in the third row. So we need that next. So let's get that. So that's going to be 2 multiplied by negative 2 plus 2 times 5. And then it's going to be plus negative 2 multiplied by 11. Okay, so we'll have 2 multiplied by negative 2 plus 2 times 5 plus negative 2 times 11, and I get negative 16. So maybe if you'll get the same thing that I'm getting. And then we just need the third entry for our third row, and we'll pretty much be done. So that'll be 2 times 4 plus, it's going to be 2 times negative 6 plus negative 2. It's going to be times 14. And so let's go ahead and get that. So we'll have 2 times 4 plus 2 times negative 6 plus negative 2 times 14. And I get negative 32. So maybe you got the same thing with me. Okay. So now all we have to do is write out our resultant matrix. So the first entries, or the entries along the first row are going to be, well, let me say it like this. This would be the first entry in the first row, second entry in the first row, third entry in the first row, first entry in the second row, the second entry in the second row, and then the third entry in the second row. And then for our third row here, this would be the first entry in the third row. This would be the second entry in the third row. And this would be the third entry in the third row. And that will essentially give us our resultant matrix. And remember, when we're multiplying these matrices, the matrix is, in this particular case, going to be of the same order that what we started with, which would be a matrix of order 3 or a 3 by 3 matrix. So let's go ahead and write down our final answer for this when we multiply these matrices here. And so matrix multiplication, a little bit involved, but again, I don't think it's that bad. Just kind of give it a little practice. So give it a practice. So when we multiply the two matrices A and B, the following resultant matrix, which we know is going to be of the same order, looks like we'll get negative 5, positive 19, 6. We got negative 57. We got 99. We got a positive 38. We got a positive 24. We got a negative 16 and a negative 32 when we actually multiply them. And so that would be your resultant matrix when we multiply the two matrices together. So that's going to be A times B. All right, so hopefully you were able to see how the whole matrix multiplication thing went, or how you do it. So just let me know if you got any questions about it. But yeah, that's going to be it. So I will see y'all next time.